Welcome to a lesson on angle bisectors. You can see in the diagram there on the screen that I have it labeled so that the two smaller angles are congruent, the single marking on each one. So it's true here that angle ABD is congruent to angle DBC. It's also true that they have the same measure. If I wanted to use the measure of the angles, those would be equal. And maybe I should talk about that. If you're going to talk about the value of the angle size, usually in degrees, I would say the measure of angle ABD is equal to, so I don't use congruent because I'm talking about the number, the measure is equal to the measure of angle DBC. Okay, and since those are equivalent, we say that the line segment BD is an angle bisector. It cuts this angle exactly in half, whatever the measure is. So I say BD is an angle bisector for angle, or I could use the angle marking, angle ABC, the big angle. All right, let's take a look at another example. Down below here, you can see that I have this more complex drawing. I have 57 degrees marked off there. I have another angle bisector. You could create all kinds of algebraic problems about this. For example, if I said that the measure of angle ROT, is equivalent to some value. I could make up any value I want because this is probably not to scale anyway. Let's say it was 152 degrees. There is a way algebraically to solve for the other angles marked there because you can use the idea of equivalency. Let's take a look at an angle bisector using GeoGebra. Again, starting off with two arrays to create an angle for ourselves. There's an array that share a common endpoint. Now I have an angle. If I wanted to bisect that angle, I believe it's a construction tool. If I can find that, construct, it went too far. Find the construct menu at the left. Notice that it does have angle bisector as one of the choices. You choose that. The directions say select 3 points or 2 lines. I'm going to select 2 lines. I'm going to select the bottom line or bottom ray AC, and then the top ray AB, and it cuts it right in half. Now notice it added a whole bunch of extra lines. So if you want some of that to go away, you could create a point anywhere on this that's subject to it. Notice I created the point D. It'll move back and forth there. If you want to clean up your drawing a little bit, which I often do, you can click on the pieces that you don't want, right click, go to settings and say, don't show me that object. You could even click on this one, don't show me that object. And now you just have this point D that's in the interior. But if you were to create an array, let's say you didn't want that full line. If you were to create an array that goes, missed it, from A through D, then now this is a dynamic drawing. Okay, in other words, when you moved any one of these points that moved, it stays fixed as an angle bisector. Really, really nice. So that if you measure the angles, you measure the angle here, you can see that's 19 degrees. Measure the angle here, that's 19 degrees. Let me move that a little bit so you can see that just a tad better. That's 19 and that's 19. Now the dynamic picture, when you move any one of these points, will remain so that those two angles are congruent. I hope that helps.